Hi second year students, it's math with AUB. Let's continue our journey of the new book of National Book Foundation that still hasn't been published. Exercise 3.2, it's part number 2. From 11 to 18, 1 to 10 we have done in our previous video. From 11 to 18, without wasting time, let's start our business. 11 reads as tan square 2 theta plus cot square 2 theta d theta. Simply ask yourself, is it differentiation of something? The answer is definitely no. Is it a function? Is it differentiation of some function? Isn't so? So that is not the case. Try to convert them by utilizing identities in function where it is a direct differentiation of something. Direct differentiation of something. Your first thought might be tan square is given by sin square over cos square. But hang on. Differentiation of cos is only sin, not sin square. And differentiation of sin is not 1 over cos square. So this strategy isn't works. If there is sin, if there would have been sin, then it's our function derivative. Function are derivative, but that is not the case. There is square. So this strategy fails. If we utilize the identity 1 plus tan square is equal to sec square 2 theta minus 1 plus simply separate divide d theta plus cot square means cosec square 2 theta minus 1 d theta. Here, yes, sec square is the differentiation of tan. Bingo. 1 is the differentiation of theta. Cosec square is the differentiation of minus cot. And 1 is differentiation of theta. And we have cracked the nut. It is sec square 2 theta d theta minus 1 times d theta plus cosec square 2 theta d theta minus 1 d theta. Sec square is the differentiation of tan, so its integration is tan 2 theta. Look at the angle. It has some multiple 2. Differentiation of angle, that is 2 theta, is 2. Differentiation of the angle is 2. So divide by the same. 1 is the differentiation of theta, so integration of 1 is theta. What about cot? Differentiation of cot is minus cosec square. Differentiation of cot is minus cosec square. There is positive cosec square. So its integration is given by minus cot 2 theta. What is the differentiation of angle? That is 2. There is a deficiency of minus, negative sign. Differentiation of cot is minus cosec square. So I have taken this deficiency here. Minus differentiation of cot is minus cosec square, minus plus, and you will get the same result. So if there is minus missing, introduce here. And 1 is the differentiation of theta. So 1 is integration of 1 is only theta plus integration constant c. We can write this as 1 over 2 tan 2 theta plus minus 1 over 2 cot 2 theta minus theta, and minus theta, it will become minus 2 theta plus c. It's our simple answer. In question number 2, we are asked only integrate, not done verification by differentiation. We haven't asked in first question, not in that. Here it is tan square. Ask yourself, is it differentiation of something? It is not the case. Similarly, same for the cot square. Same goes for cot square. Tan square is equal to sec square theta minus 1. Inspect the situation. Yes, sec square is differentiation of tan. So integration of sec square is only tan. Here, angle has a multiple 2, divide with the same. 1 is the differentiation of theta. So integration of 1 is theta. Cosec square is the differentiation of minus cot. Minus cosec square, it will become positive. Differentiation of cot is minus cosec square. Minus is missing. I have introduced here. Similarly, angle has a multiple of 2 dividing with the same. 1 is the differentiation of theta. So integration of 1 is theta. Simplifying 1 over 2 tan theta. 1 minus 1 over 2 cot 2 theta. Minus theta, it will become minus 2 theta. It's our answer. It's our answer. Whether tan and cot has even power or odd powers, utilize these two formulas to open your path for further solution. Further solution. Question number 2. In the first exercise or in first portion, we have done a question cos square z over 7 dz. I have I have shared with you how to handle sine and cos when they have even powers. Look at this. It is our sine square, angle is 11 over 2 y dy. Sine square is not differentiation of anything direct. Sine square is not differentiation of anything direct. So does cos square. I have told you when sine and cosine have even powers, always utilize these identities. Sine square theta, it's equal to 1 minus cos 2 theta over 2 for cos square. Here comes the positive only. 1 plus cos 2 theta over 2. That's our study. Here it is sine square, introducing this same formula. Sine square is 1 minus cos double the angle 11 over 2y over all 2. Here is dy. Instead of theta, we have 11 over 2y. I have this 2 to cancel in angle. 1 over 2 outside. I have 1 minus cos 11y dy. 1 is differentiation of y. So integration of 1 is y and integration of cos is only sine divided by 11. Simply multiply 1 over 2 integral and dy throughout. 1 dy minus 1 over 2 cos 11y and dy. Integration of 1 with respect to y is only y minus 1 over 2. Integration of cos is only sine 11y. Don't forget, angle is a multiple of 11 divided by 11 r. Simply you can reconcile this fact that differentiation of 11y is 11 dividing by the same. In case of differentiation, we have to multiply with the differentiation of angle. In case of integration, we have to divide. It will become 2 times 11, 22. So our answer is 1 over 2y minus 1 over 22 sine 11y plus c. It's our answer in that case. Look at this. When sine and cosine have even powers, I have shared with you that is the strategy to be adopted to integrate. Sine square is 1 minus cos 2 theta over 2, cos square is 1 plus cos 2 theta over 2. Sine square has even power at the start. Utilizing this identity, just double the angle. 1 minus cos 2, double the angle, and 2 angle is same. 2 to cancel 11y. Integration of 1 is only y. Integration of cos is sine 11y. The rest are the constants we have managed. The angle is multiple of 11, we have divided with the same. And smoothing the situation by multiplying 2 times 11 is 22. Question number 30. Question number 30. It's need that integrate cosec 11x times tan 11x dx. Cosec 11x tan 11x dx. If there would have been sec and tan is the differentiation of sec. If there would have been sec, its integration is only sec. But here this is not the case. There is cosec, there is tan. The second possibility, function derivative. Differentiation of cosec is minus cosec and cot, and differentiation of tan is only sec square. That is the not case here. In that case, be a child of trigonometry. Utilize simple identities. Try to convert whole trigonometric function in sine and cos. Cosec is the reciprocal of sine. 1 over sine 11x. Cosec means 1 over sine 11x. and tan is sine 11x over cos 11x. We have paved the way for our solution. Cancelled out. We have 1 over cos 11x dx. Reciprocal of cos is sec. That's sec 11x dx. And integration of sec is ln sec 11x sec x plus tan x angle shape sec 11x tan 11x plus c. Here additional number 11 has been multiplied with angle divided with the same. That's our answer. That's our answer. Integration of sec is, let me write in the frame to emphasize the situation. Integration of sec is ln sec x plus tan x. Ln sec x plus tan x. For a curious mind, from where comes or occurs the integration of sec is ln sec plus tan. Let me explain this portion. To be kept in mind for direct utilization. If you are interested from where comes or occurs this, let's see and find out. Integration of sec is ln sec plus tan. Here, integration of sec x dx. Sec, we are familiar. The differentiation of sec is sec x as well as tan x. And differentiation of tan is sec, differentiation of tan is sec square x. Differentiation of sec is sec as well as tan, number one. Number two, differentiation of tan is sec square x. Differentiation of tan is sec square x. Differentiation of tan is sec square x. Okay. Here, if we multiply and divide by sec plus tan, dividing and multiplying by sec x plus tan x, multiplying as well as divide. Sec x plus tan x, multiply sec throughout, we have sec square x plus sec x tan x dx overall sec x plus tan x. Overall power 1, you are going to get some good clue from this. Differentiation of sec is sec x tan x and differentiation of tan is sec square. So it's our differentiation, it's our function. Function derivative, function derivative, function derivative, and function is in the denominator. That's the situation here. Differentiation in numerator, function is in the denominator, having overall power 1. Its integration is ln the function in denominator, ln the function in denominator. Here same situation prevails. This is our function, this is our derivative. Function has overall power 1, overall power 1, as I mentioned several times. Function derivative, I have written function derivative, function having overall power 1, overall power 1. It is the case of ln function. Ln, the function is in the denominator, that is sec x plus tan x plus c. That's the answer to a curious mind. From where comes or occurs the integration of sec is ln sec plus tan. Integration of sec is ln sec plus tan. Moving towards next question. Question number 14. Cos theta times bracket tan theta plus sec theta d theta. Cos theta bracket, cos theta times bracket tan theta plus sec theta. We have cos theta times bracket tan theta plus sec theta d theta. If I want, differentiation of cos is minus sine, differentiation of tan is only sec square, differentiation of sec is sec as well as tan. So function derivative situation doesn't prevail here. Function derivative situation is not present here. Be a child of trigonometry, utilize the identity, try to convert all the functions of trigonometry in sine and cos. It's already in cos, keep it intact. Tan is given by sine over cos plus sec is 1 over cos times d theta. Here, denominators are homogeneous. Write one time, no transition in the numerator. I have cos theta times, cos is the LCM, numerator remains same, sin theta plus 1 d theta. This cos cancelled out. I have only sin theta plus 1 d theta. Multiply integral symbol and d theta throughout, sin theta d theta plus 1 d theta. Integration of sine is minus cos. Integration of sine is minus cos, while differentiation of cos is minus sine. Differentiation of cos is minus sine. Differentiation of cos is minus sine. Integration of sine is negative cos. Angle is simple one. Integration of angle is 1. Divide with 1 or not, it's up to you. Integration of 1 is theta with respect to theta. So we have minus cos theta plus theta plus c is our answer in case question number 14. Question number 14. Ask yourself, is it function? Differentiation of cos is minus sine. Tan, differentiation of tan is sec square. Differentiation of sec is sec as well as tan. That is not the case. Then become a child of trigonometry. Convert all the functions of trigonometry in sine and cos. It will pave the way for your solution. Moving towards question number 15. That is cosec square. Angle is not simple one. Angle is inclination is x minus 1 over 3 dx. Cosec square x minus 1 over all 3 dx. X square, x cosec square, x minus 1 over 3. Integration. Cosec square is the differentiation of minus cot. Cosec square, positive cosec square is the differentiation of minus cot. Its integration is minus cot. Its integration is minus cot because differentiation of minus cot is minus cot with respect to x is minus differentiation of cot is minus cosec square x minus plus cosec square x. We have to settle down the argument issue, angle issue. Suppose y is equal to x minus 1 over 3, or it can be written as y is equal to 1 over 3 times x minus 1. Differentiate with respect to x, dy over dx, it's equal to 1 over 3. Differentiation of x is 1 and 1 is 0. So we have dy over dx is equal to 1 over 3. Finding the value of the differential dy, it's 1 over 3 times dx. 1 over 3 times dx. But here we need only dx. Shift 3 here. It will become 3 dy is equal to dx. 2 is our number 1. Put these values here. Instead of this, introduce y. Instead of this, 3 dy. So we have something like this. Cosec square y times 3 dy. Cosec square y times 3 dy. 3 is a constant to be written outside. Cosec square y dy. Now ask yourself, is it differentiation of something direct? Yes. Positive cosec square is the differentiation of negative cos. Positive cosec square is the differentiation of negative cot. So its integration is 3 times negative cot y. 3 times negative cot y. Reput the value of y, that is x minus 1 and 3. Let me check whether I am in frame or not. I am. I can write one step more. 3 times difference. I have done this. Minus 3 cot value of y is x minus 1 over 3 plus c. That's our answer. Look at this. Cosec square is the differentiation of negative cot. Cosec square is the differentiation of negative cos. We have reconciled the issue of angle. Angle is not simple one. Suppose angle is x minus 1 over 3. Differentiate dy over dx is equal to 1 over 3 times 1. Solve for dy. Dy is equal to 1 over 3 dx. Here x equal to y, we need value of dx from the derivative. Shift 3 here. So dx is 3 times dy. I have put both these values. Instead of this, cosec square y, it's r dy over 3. Cosec square y, 3 dy. Cosec square y, 3 dy. Cosec square y, 3 dy. I have written this. Cosec square y, 3 dy, 3 outside. Direct integration of cosec square is minus cot, because differentiation of minus cot is positive cosec square. Differentiation of minus cot is positive cosec square. Positive cosec square. I have done so. Minus 3 cot, minus 3 cot, 3 minus cot y, minus 4, then 3 cot. We put the value of y. That is x minus 1 over 3. That is x minus 1 over 3, and it's our answer. Moving towards question number 16. It will open you up, it will open your horizon, broaden your horizon. In integration, I have already told you, to hunt function and derivative. To hunt function and derivative, it's a wonderful thing for you to solve integration with this strategy. Cos x raised 1 over 2 times sin x dx. It's a simple situation of function derivative. Differentiation of cos is minus sine. Differentiation of cos is minus sine. Let me attempt this for direct. There's deficiency of minus, write 2 times minus cos raised 1 over 2 minus sin x dx. Minus sin x dx. So this is our function. This is our differentiation. Function derivative, function derivative, function derivative, function derivative, function derivative. Add 1 into the power of function. It will become 3 over 2 dividing with the same 3 over 2 plus c, or it can be written as minus 2 over 3 cos x raised 3 over 2 plus c. It's our answer. It's our answer. It's our answer. Function derivative, function derivative. There's a deficiency of minus. I have written 2 times minus, minus times minus, minus minus times plus. Its function, now it's complete derivative. Deficiency of minus has been removed. Function, complete differentiation, add 1 to the power of function. Or you can adopt a lengthy strategy, but it will facilitate your understanding. Suppose cos x is, assume that, suppose y is equal to cos x. Differentiating with respect to x, dy over dx. Differentiation of cos is minus sin x. Shift dx here. Dy is minus sin x. Following the orthodox tradition, suppose y is equal to cos x. Suppose. Assume that y is equal to cos x. Differentiating dy over dx. Differentiation of cos is negative sin x. Solve for differential y. It will become minus sin negative times sin x dx. Look here, we have, suppose it's y, we have to find the value of this one from differentiation. We need only sin x dx. Multiplying by minus, we have negative dy is equal to sin x dx. Put these two values in the original integral, we have something like this. Y raised 1 over 2 negative dy. Writing negative symbol outside the integral, y raised 1 over 2 dy. Now it's simple integration. Just add 1 into the power of y and divide with the same, minus 1 upon 2 plus 1. It is our 3 over 2. 2 LCM, 1 plus 2, 3 over 2. Dividing with the same, plus c. Owing to double upon double division, it will become minus 2 over 3. We put the value of y. That is y is equal to cos x plus c. It's our answer, as we have done earlier. A question arises, why we are taking this as a function, not this one? Look, this is the power obstacle. If power is fraction or power large, then it base has the capability to become a function. This is simple one. It's our derivative. It might be our derivative. We are taking cos as a function owing to its power. owing to its power, owing to its power. Suppose base without taking power, y is equal to cos x, differentiation of cos is minus sine. We have managed the show. This is why we need the value of this one, sine x dx, that is dy minus sine x dx multiplying by minus. So sine x dx is equal to minus dy. Putting both of these values here, y times 1 over 2 times minus dy, right? Minus I outside, it will become a simple integration. Just add 1 into the power of y, dividing with the same. Owing to double deviant, it will become minus 2 over 3. They put value of y, that is cos x3 over 2. Moving towards next question, that is integral e raised y exponential y times sine angle exponential y dy. We have e raised y sine ey dy. Look at this. What is the angle? Angle is not the simple one in that case. Angle is not the simple one in that case. How to approach this question? Okay, let's differentiate sine ey with respect to y. Differentiate sine e raised y with respect to y. It will become differentiation of sine is cos, angle is same, then differentiation of the angle, differentiation of e raised y is same, e raised y, e raised y. So integration of this one must be sine ey, sine ey, sine ey, or differentiate cos y, differentiate cos e raised x, it will become differentiation of cos is negative sine e raised x angle same, then differentiation of angle, that's our e raised x, e raised x. So by virtue of entire derivative definition, integration of sine raised sine angle ex times ex is cos ex with the tiny deficiency of minus, we can manage, we can manage. So if we suppose x is equal to e raised y, x is equal to e raised y, differentiate with respect to y dx over dy, differentiate with respect to y. Here the variable changes, here y is the variable and we are supposing x. Differentiation of e raised y is same, shift dx there, on the right hand side e raised y dy. Look at this one, let me arrange the data for you. Here it is. Let me write this as sine e raised y times ey dy. So this is our x, we put the value here, it's our x and it's our dx, sine x, and it is our e raised y dy is equal to dx, sine x dx. So integration of sine is only negative cos plus c, we put the value of x, that's e raised y, we have minus cos e raised to y plus c, it's our answer. Or one can verify by differentiating the answer, we will get this. Let's see how. Differentiating the answer differentiating the answer by differentiating, we have negative cos e raised to y. Differentiation of cos is minus sine angle same, then differentiation of angle, it's our e raised to y, minus minus plus, we have sine e raised to y times e raised to y, that is the data we have given to us. Don't you worry, is it differentiation of something direct, or that is function derivative situation? They are both coupled here, linked here. You have to open them in a fine manner, you will arrive at the result. If you feel still difficulty, take the major function and differentiate. Take the major function and differentiate. Take the major function and differentiate. It will give you a good idea. It will give you the good idea what is going on. Okay. Our final question of today's frame, and the simple one too. We have already managed what is the integration of tangent, that is ln sec, we have already proved. Let's discuss this again. Integration 9 times tan x plus 7 dx, 9 outside, tan x plus 7 dx. Here angle is little bit complicated. Suppose y is equal to x plus 7. In order to understand the situation fully, suppose y is equal to x plus 7. Differentiate with respect to x. We have dy over dx 1 plus 0. Solving for dy, that's our dx. Number 2, number 1. We put here, it's our y, it's our dy. So we have something like this, 9 times integral 10 y, and it's our dy. Integration of, sorry, I have written 9 log of life graph. It's our 9. 9 integration of 10 is ln sec y. Let's see what is value of y. We put sec, value of y is x plus 7 plus c, and we have proved in the previous frame how integration of 10 is ln sec. For a curious mind, one time more we are proving integration of 10. Let's see and find out. 9 outside, 10 can be written as sine x plus 7 over cos x plus 7 dx. Okay, differentiation of cos is minus sign. There's only deficiency of minus, and function has overall power one. In order to emphasize, underline the importance of this. Whenever function is in the denominator having overall power 1, function is in the denominator having overall power 1, it is the situation. Differentiation in the numerator, function is in the numerator having overall power 1, its integration is ln the function present in the denominator. Okay, suppose y is equal to cos inclination is x plus 7 argument, differentiate dy over dx, differentiation of cos is minus sine. We have right angle same. Then differentiation of angle, differentiation of x is 1 and 7 is 0. Multiplying with 1 is of no effect. It is a multiplicative identity with respect to multiplication. Shift dx here. So dy. We need the value of sine angle x plus 7 dx. We don't need minus. Multiply negative both sides. We have negative dy is sine x plus 7 times dx. That's our 2. That's our number 1. Both put here. So we have some sort of situation like 9 outside. It is our minus dy over y, right? Minus outside, minus 9 1 over y dy. It's the case derivative function is in the denominator, differentiation derivative function is in the numerator, or sorry, denominator having overall power 1. Function is in the denominator having overall power 1. Differentiation in the numerator, that's the case here, and function has overall power 1. It is case of ln y. Report the value of y minus 9. Ln value of y is cos angle is x plus 7 plus c. By virtue of a tiny log property, we can manage this minus to the power of cos as 9 times ln cos x plus 7 raised minus 1. By virtue of this ln, a raised b can be written as b times ln a, and vice versa. So this power quotient can be turned to a power. I have taken only one. Here. That is how to make exponent positive. It will become 1 over cos x plus 7. We know that the reciprocal of cos is sec 9 times ln. Sec angle is same x plus 7 plus c. It's our answer that we have just proved in some while ago. That's our answer in that case. It's my tiny effort for you guys to explain to you integration from the new book. And tomorrow, inshallah, we are about to embark upon exercise 3.3. It's all by itself. Next.